Hey guys, welcome back to ClearCutCode, and today we are going to solve problem 2 sum 2. There is the second part of the problem 2 sum which is already available on our channel. You can check it out. So now if we take a look at the problem statement, given a one indexed array of integers numbers that is already sorted in non-decreasing order, find two numbers such that they add up to the specific target number. Let these two numbers be in numbers of index 1 and numbers of index 2, where 1 is less than or equal to index 1, which is less than index 2, which is less than the length of the numbers array. Now return the indices of the two numbers, index 1 and index 2, added by 1 as an integer array, that is index 1 and index 2 of length 2. The tests are generated such that there is exactly one solution. You may not use the same element twice. Also, your solution must be only constant extra space. So any solving any problem, the first thing that we have to do is understand the problem statement. So from this, what we can gather is we are given similarly to the first problem, that is to someone. If you haven't checked it out, you can check it out. So similar to the first problem, again we are provided with an array of numbers which and the target. Now we have to find two numbers such that their sum is equal to the target. So again, what is the difference here? So the difference is that we this time the numbers array that we are provided, it's going to be sorted in a non-decreasing order, which will make our solution like much easier. And at the same time we have to this time use only constant extra space, so we cannot be using a map to do this. Now, if we take a look at the sample test cases to further understand this problem better, we are given an input of numbers, that is 2, 7, 11 and 15. Our target is 9. So here we can see the output is 1 and 2, which is the first and the second element, which will, if you can see, 7 and 2, which will add up to 9. So that is our solution. Similarly, if we take a look at the second example here, we can see we have the input of 2, 3, 4. Now the output is 1 and 3, which is the first and the third index, which here we can see is 2 and 4, which will add up to 6. So we can understand that what we are doing here, we are taking any two numbers from the given answer and we are adding them to find the target. Now what's the difference? The difference is that we are given a sorted input, so that changes our thing. We don't need to use a map or something to just traverse through the whole array. Of course we can still do this question using a map, but as we are set to only use constant extra space, we won't be using that solution. So what is the other solution that we can use that comes into our mind when we heard a sorted input? Of course, it's two-pointer approach, and the two-pointer approach that we are going to implement is going to be similar to a binary search, where we'll be decreasing the search spaces according to the solution. So now if we take a look at it here, so this is the first test case. Now using general maths, what we need to do is, if I plus j, where I is starting at the first index, which is the first pointer, and j is starting as the last index, we know that if these two numbers are like having some value that is k. Okay, now if I want to decrease the value of k, what we need to do? In a sorted array, j is pointing at the last index, which is going to be the largest number in this between these. So I is going to be greater than j. The value of j is going to be greater than I. So I will have to decrease the value of j to decrease the value of k. So that's what I'm going to do. I will decrease the value of j, which is going to be j minus minus. Similarly, if I want to increase the value of k, what I can do, because this is already the bigger number, I cannot increase this anymore. So instead of that, I will be increasing I. So if I increase I, the value of k will also increase. So what I can do is I can increase the value of I. Now if we take a look at the example here, 2 and 17, 2 and 15, if we take 2 and 15, we will get a sum of 17, which means if I want to decrease the value of 17, what I can do is move the value of j to the right side, which will, if point here, this will become 11, and the final solution, like the final output of this expression, is going to be 13. And what if I want to increase the value from 30? What we can do is we can change I to position here, and this will become 7, which is going to be a 7 plus 11, which is end up 18. Okay, so this we know how it's going to work. Now for our target, if our target is 9, can't we just compare the sum that we are getting to find this? So like how we can do is, if I compare the sum here, let's do this. So if I compare the current value, that is 2 and 15, So 2 plus 15 is going to be 9, is not equal to 9. What is it? This is 17 and 17 is greater than 9, which means I need to decrease the overall value of this expression. To decrease the overall value of this expression, what we are going to do? We are going to do a j minus minus. That means j will be moving here. Now, what is the new value? The new value is going to be 2 plus 11, which is uh, 2 plus 11, which is 13. Now 13 is also not equal to 9, and 13 is again greater than j. So what we are going to do? We are going to cut j from here also, and we are going to move it here, which will give me this. Now j plus I, that is 7 plus 2 is 9. Now this is equal to the target that we needed, these two values. So what we can do is just put this and return this as our answer. So let's now try to code this. So I have already written the code here. As you can see, this is a vector twosome in which we have to write the code, and they are already providing us with the numbers and the target that we needed. So all we need is to do is initialize two variables, I and j in this case, with 0 and end sum, that like last element of the numbers array. So initial element and the last element. Now while I is less than j, to understand this particular expression, what you need to understand is that when once I and j cross places, you are going to repeat the numbers, you are going to repeat the combinations that you have already taken. So when as soon as I and j crosses the place, we know that there is no other solution existing. In this case, we are not going to face that problem because they is already told that we have exactly one solution available. Now, similar to our explanation back there, we can see if numbers of I plus numbers of j is less than the target, that what we need to do? We need to increase the lower value. The lower value is contained inside the ith index. So we are just going to increase the ith index, which is going to be I plus plus. And the opposite, if the value is greater than the target, then we need to decrease the increasing number in the expression, that is this, which is j. So we will just decrease the value of j. And what if we get the target? Once we get the target, all we need to do is push back I plus 1 and j plus 1. Why I plus 1 and j plus 1? Because they have told us to return it by adding 1 to it, which is going to give them a one indexed based answer. And finally we can break it so that we don't have to look at the other pairs, and here we can return the result. And that is how we can do it. If we submit it here, um, we can see that we are getting it's submitted, and we are getting quite a nice value too. Of course, this depends on your internet connection too. So like for the time complexity, we are going to going with a big of n, because we are only traversing the numbers array once. Okay, so we are only traversing the numbers array once, and that is also in the worst case that we have to traverse the whole array, or else in the best case it's directly going to give us the first and the last element, which will be your answer. So big of n is the worst case average and the worst case time complexity, and for the space complexity is constant, because we are only using I and j as our variables, and this is always going to have a length of 2, nothing else. So we have a constant time complexity here. Thank you for watching the video. If you liked it, please consider subscribing and liking the video, and in the comment let me know if there is any updates or any suggestions that you have. Thank you.